Okay, in this tutorial, I'm talking about one of the online calculators for LSRLs. It's essentially an alternative to using spreadsheets. So I did a spreadsheet tutorial for the hours spent studying versus the math SAT scores. You can see it here on my previous ones. And now we're going to try out this other online calculator to see kind of how it holds up. So you'll see it in week 4, but it's also here in the online calculator tutorials. Go down to useful online calculators, and right here, an alternative to spreadsheets for linear regression. So you'll click on this, and now you need to copy and paste in here. This does copy and paste fairly well from my open math homework. In general, most of my open math homework questions paste well into spreadsheets. So if you can't get it to paste well into this calculator, you can open up a spreadsheet, copy and paste it into spreadsheets, and then copy and paste it into here. So I'm even going to go ahead and copy and paste our headers, just because why not? I might as well. So that way I don't have to keep going back and I know exactly what I have going on. And we're going to go and highlight, hit copy, and then click in here and hit paste. And we can see that it did nicely. It said separate the data by inner or a comma. We already know that our hours spent studying is going to be our explanatory variable. The X variable, the column on the left, always needs to be, when you're copying into this calculator, always needs to be your explanatory. And this one always needs to be your response variable. All right, and oops, now we're going to go ahead and highlight this data, hit copy, and go in here and hit paste. Okay, so we've got our data and I'm going to make sure that it's matching up. Let's pick something like this 13 and make sure I've got 730. And that's what I was supposed to. Okay, so things kind of pick something in the middle or towards the end to make sure that things are lining up correctly. Just really worth the quick double check just to make sure that you're happy with it. You do want to make sure that you're using the simple linear regression. The link does take you to that specifically. Don't worry about this. The effect type, though, we are looking for R squared. So go ahead and change that. The digits, well, if your my open math problem, once you go out to more significant digits, you can go out to as many as 10. I'm going to keep it at 4 right now. Don't do this. Keep your step-by-step on so that you can see what's going on. And don't hit that. This lets you hit what you had done before. And we're just going to hit calculate. So this does give you a scatter plot, but unfortunately it doesn't give you a scatter plot without the line, which is one of the requirements for our paper. So you do need to know how to make a scatter plot on spreadsheets or some other calculator so that you have a copy of that somewhere. So you can see it puts in triangles your y hats and in circles your y's. So remember, the y hat is the expected value, so the value that the line is telling you that you should be getting, and then the blue dots, that's the observed value. So those are the values that you actually wrote down as part of your data set. And we can see what a nice, beautiful correlation we have. And we can see it's got, I always think this is kind of a silly but nice way to look at things. So it looks like a strong correlation is going on here. What we want to look at, and then it does a residual plot here for ourselves, so a residual scatter plot. You can watch one of my other videos to talk about that. I'm just kind of talking through all the different things that we've seen. It gives you some real quick things. So up here, it gives you your R squared value, so 0.87. I think it gives you a better R squared down below. It gives you your P value, which we're not there yet, so hold off on what that is. We will talk about that later on. That's not something that we are doing right now. So these things I'll get to next week. I'll make a video about what's going on in here. Those are going to be useful for us next week. Okay. So this week, what we want to look at is R squared. So your R squared value is right here. It's out to the 4 digits that you asked. I do like this calculator because it reminds you what R squared represents. And then you have R. And remember, if you don't ever know what R is, but you have R squared, you just square root it, and then it always gives you a positive number. So you want to make sure, do I have a positive correlation? If I have a positive correlation, my R value is also positive. If this had been a negative correlation, then my R value should have been negative, because your R value matches to the same signage as your slope. Don't worry about this. Again, we'll talk about this later. This is not for us right now. Outliers, this one is telling us that it doesn't have any outliers, which is, I think, what we got before. It does show us our residual histogram, and this is for as small of a data set as we have, this is relatively normal, so is acceptable. It does do a lovely job of all those big, scary equations that I told you to kind of ignore. Here they are right here, and you can see them down here. Again, we can talk about these some more and about where they are coming from. So it is nice because it does do a little bit of that stuff for us. And we are looking for, the thing that it doesn't do is it doesn't calculate our S value. Go ahead and pause this 1 second so I make sure I am saying the right thing. Sorry for that jump in the video. I wanted to make sure I was pointing out the right numbers and I forgot to check before I came on. So to actually calculate, so it does say that it calculates whether or not there are outliers. I don't know if it shows you how it does that. I haven't done this calculator in a while. So just as where it shows you those things, I think that's important to know where those values are. I don't believe, even if it has outliers, I still don't believe that it shows you the value of S and that you have to calculate that yourself. So let me just show you where those things are, though. It does give you the things that you need. So if we go back to the formula for S, remember, S is the standard deviation of the line. And unlike with a traditional data set where you use IQR to create your outliers, instead, what we're doing is we're using S and we're comparing that to the size of each residual. So we really want to compare 2 times S. Well, S is the square root of the SSE divided by n minus 2. And let me just show you where that value is right here. If you come back up here and you go to where it says residual, and you look right here, 18, this is actually n minus 2. And then this right here where it says sum of square, that is the SSE. So the SSE stands for the sum of the square. So what we're trying to do is we're trying to take this number here and divide by this number here and take the square root of that whole thing. So if we go ahead and pull up another one of my favorite calculators, which is just Desmos Scientific. It's just a basic calculator. I'm not sure if I can highlight this guy or not. And it won't let me, but that's okay. So I can go ahead and hit square root. And let's see, 44493, 44493 point, oops, I got to be inside of that square root, 44493 point 5556 5556 divided by, and 0.555, no, I didn't like that, 0.5556 divided by, I don't know why it decided to try and pop out of my, it's probably because I went away. So make sure that you're underneath that square root sign the whole time. 18 divided by 18. And so our standard error that we're using for deciding whether or not there are outliers with the residuals is that 49. What you can do is hit enter and that'll put it up above. So you can go 49.7178 times 2. And now I need to know, now I can go and look 99.4. I'm going to go check out my residuals, which if I come back here to my regression calculator, it actually did calculate my residuals for me. And I can make sure are all of them smaller than 99. Well, I've got 64 and I go and I look and I go 44, all of Those are smaller, 57. Ooh, it lied. We actually do have an outlier. So do not trust the data does not contain outliers. This calculator is a liar. So don't trust that. You will have to go and find it yourself because 120 is larger than the 99.43 that we suggested that we should have for an outlier. So this set does in fact contain outliers. Okay, well, there you go. So you got to be really careful when you use this calculator. It's great up until a point. And that is the thing with almost all of our calculators is that they are really great up until a point.